Phasor Edition full example. What I'm going to do here is a full example of the first question on the Phasor Edition worksheet. Looks like this. Let's go through it step by step and make sure we all have the same ideas as to what is required or necessary in order to achieve this. I'm going to leave all the sketching of the actual phasors to the very end on my Cartesian plane, which is the fancy name for that particular type of information graphic. And we are going to start over here with the HV table. So first things first, we need to take the two separate phasors and input them into the first two lines of our HV table. So that is 18 volts at 200 degrees. Second one down here is 70 volts at 91 degrees. It does not matter which one goes above or below because what we are doing here is adding them. And since we add them, it makes no difference, right? So you can think of this as a sum table here. We're going to add those and add those. Next thing, we need to work out the horizontal and vertical components. And in order for us to do that, we are going to use cos theta. And cos, I always got to think of it, so ca is adjacent over hypotenuse. And then sine theta is equal to opposite over hypotenuse. Man, that hypotenuse looks really bad. There we go. H, oh, I think I just made it worse. Whatever. Cos theta is equal to adjacent over hypotenuse. Sine theta is equal to opposite over hypotenuse. So for cos theta, what we need to work out is the adjacent side. And so what that means, or what I mean by that, is that with this, we're going to work out the horizontal. And the horizontal of a triangle, when we're looking at it from this angle, is always here. And this would be the opposite. When we're doing our sine, well, that's going to use a different form, right? So that means that in order to get this, we need to take our formula, which is cos theta adjacent over hypotenuse, and adjust it for this. Adjacent is equal to cos theta times hypotenuse. Pretty simple. Okay, so what we're going to do is take our angle. We're going to, well, first we're going to enter the cos trig function in our calculator. Then immediately we're going to enter in the angle, then the multiply symbol, and then the magnitude of our vector. Because remember, the hypotenuse is here. So let's go back to this. That means that for my calculator, I'm going to take and put in cos 200 times 18. And it gives me negative 16.91. What about the vertical component then? We're going to do the vertical of this particular phasor, and in order to do the vertical, that is here, right? Vertical. And that means that we are working on the opposite. We want the opposite side, right? So we need to then manipulate the equation and take this opposite over hypotenuse and convert it so that we have opposite alone. And that requires us to multiply both sides of the equation by the hypotenuse value. So that means sine of the angle times hypotenuse. So what are we going to do? We're going to enter in the trig sine button, then immediately the angle, and then the multiply symbol, and then we'll type in the hypotenuse magnitude. So let's go and do that. We've got our calculator here. We're going to enter in sine 200 times 18 gives me negative 6.15. All right, for the second step down here, I'm going to enter in with my calculator, same thing as before, cos of my angle, which is 91, times 70, gives me negative 1.22. And then over here, vertical, that would be, well, sine 91 times 70, 69.98. You need to add these together, taking into account their polarities. And so the easiest way to do that is use this button down here. There's your negative symbol. And all I'm going to do is I'm going to add these things up. So I'm going to add up the horizontals. So negative 16.91 plus negative 1.22 equals negative 18.13. Negative 18.13. There we go. So negative 18.13. What about the other column? I'm adding up the verticals. Negative 6.15 plus 69.98 equals 63.83. All right, so now what we have to do is work out what quadrant of this Cartesian plane that new vector is going to be. So first things first, let's look at the total vertical, total horizontal. If we look at this little diagram at the very bottom here, it's sort of showing the Cartesian plane, but in a much more basic form. I have a positive vertical value, which means that my phasor is going to have to be somewhere in this area. And the reason for that is that from this point going up is positive values, from this point going down would be negative values. So I know it has to be somewhere up here. My horizontal is negative, and so that means that it has to be in this area. So going up would be positive values, going down would be negative values. So at this point, I'm just going to sketch in here and say, meh, I know it is somewhere in there. Good, first step. Next step, what we're going to do is using our trig formula and our little bit of Pythagoras, we're going to work out everything about this new vector. So let's sketch a little triangle for it that represents it. There we go. There's the angle. We don't know that yet. And let's also fill in some of the other values. So the horizontal is negative 18.13, and the vertical is 63.83. In order to work out the hypotenuse, I think it's easiest typically to just use Pythagoras. So Pythagoras, a squared plus b squared equals, well, after you square root it, c squared, right? So I'm going to enter that into my calculator, negative 18.13 squared plus, well, here, I'll even show you, plus 63.83 squared equals, and then I'm going to square root the whole thing, we get 66.35. So 66.35, that would be the voltage of my combined two vectors. All right, so now I want to work out the angle here. And the angle, we just have to watch where our arrow happens to be sketched. So I'm going to use cos. I'm going to use cos theta, and I'm going to work out the angle. In order to work out the angle, remember, any of the trig functions will work. I'm just choosing cos, and cos is adjacent over hypotenuse. And what I'm going to do, because I already know where it is going to be located, I'm going to leave out the negative of this number. I'm going to leave out any sort of polarity indication, okay? And so all I'm going to use is positive numeric values. And that goes the same with every one of the examples on this handout. When we're going to work out the angle just here, well, it's easiest for us to just choose one of the trig functions, drop the negative symbol, and then work out what that angle is after. So if I want to work out the angle, that means I need to take adjacent over hypotenuse and then apply the inverse trig function, which is that. So that would then mean that we are taking our, well, let's work it out. Our adjacent is 18.13 divided by our hypotenuse, 66.35, equals inverse cos now. It tells me it's 74.14 degrees. All right, so let's take that number. That is the angle right here. 74.14 degrees. But remember, And this is the tricky bit, just to remember where in context that is. Phasors, when they are sketched in representation on a Cartesian plane with other phasors, are always referenced starting from 0 and going all the way around. So really what we want to know is this angle here. That's not too bad. I mean, this is 180. This is 0 degrees. So in order for us to work out the angle, I mean, it's pretty straightforward. All we're going to do is subtract 74.14 from 180, and that would give us a remaining degrees, which is then our answer. So let's take a look. We've got 180 minus 74.14, 105.86. Now there's lots of different ways for us to get this angle at the very end. And I'm going to say this is a simple method for you to use in order to get this angle. Most often in electrical and second level, we're only really going to be working in these two quadrants of our Cartesian plane. And because of that, this process won't be as crazy important when it comes to deciphering all the different circuits. But for this handout, it is important. So next step, let's write down what our actual phasor is then. We've worked out at 66.35. And we've also worked out the angle. It is 105.86. So second portion is simply to sketch them, and you need a ruler, okay? Doesn't need to be a fancy stainless steel ruler like this one, but you do need a ruler, and this is simply saying what the scale is per centimeter. So 10 volts per centimeter. So all I'm going to do is I'm going to take my 18 volts and divide it by 10, and that will give me the number of centimeters. So for my 18 volt phasor, it's going to be 1.8 centimeters in length. For my 70 volt phasor, again, just dividing it by 10 for this particular arrangement, it's going to be 7 centimeters in length. And for my 66.35, well, you guessed it, it's going to be 6.6 centimeters in length. So pretty simple. Let's take a look at where each one's going to land. First one, 18 volts at 200 degrees, it's going to be 1.8 centimeters in length. So here is my ruler. I'm just like, this does not have to be absolute precision, but let's see, 200 degrees. So 180 is there, and then 210 is here, and they're going by tens, right? So that means that we are at 180, 190, 200, and 210. So 200 would be right about there, right? And 1.8, there we go. Sketch it out. Whoop, there we go. And there is my vector. And I label it 18 volts at 200 degrees. Great. Next one, let's look at the 70 volts. That's 7 centimeters in length. And it is at 91 degrees. So there's 90. 91 is just a little bit over. So 7 centimeters. Whoa, I'm actually going to go way high. I'm going to go absolutely right through my information there, but whatever. So there we go. 7 centimeters, about like that. There we go. So that is 70 volts at 91 degrees. Great. Last one is the resultant phasor. And so what you can see is that that resultant phasor lands in between these two, right? And so that is 66.35 at 105.86. So kind of hard to fully guesstimate here, but 90, 100, 110. So we're kind of like halfway around there, right? And we're at 6.6 centimeters. So again, I'm gonna like draw a line right through everything I've just written, right? There we go, something like that. Good. Zip. Excellent. And this obviously is my 66.35 phasor at 105.86 degrees. So that would be our completed process for solving the addition of two separate vectors or phasors and then sketching them with a scale, requiring the use of a ruler and a little bit of know-how with your calculator. Hope that helps and look forward to seeing you over the next couple of weeks.